I will be presenting this workshop on whether viruses are living or non-living. That is actually quite the fascinating question, and it has stumped scientists for many, many years. Right now, we've reached a consensus on it, so most people agree on the fact that they are non-living. However, there's still a lot of debate going around, and in the public consciousness, we tend to talk about viruses as if they were living, which is why this question is so interesting. So, the scientific community has struggled for many years to define the requirements that organisms must meet in order to be considered living. So it's very clear to us that there are living things and there are non-living things, but it's a bit harder to generalize and say, okay, what about those living things makes them living, right? How can we define those? The most agreed on requirements for living things are the following ones. So they are all made out of cells. They can reproduce and pass their traits to their offspring. They use energy and nutrients to grow and develop. They can respond to the environment. They have a metabolism. And they maintain homeostasis, which is just maintaining an internal balance so they can regulate their internal states. And we find that that does a pretty good job at classifying organisms when we're looking at this kinds. So when we're looking at animals and plants, fungi, even something as small as prokaryotic organisms or unicellular organisms, such as bacteria. So for all of these organisms, we find that they're made of cells, they can reproduce, they use energy and nutrients, they grow and develop, they respond to the environment, they have metabolism, they maintain homeostasis. Now, they do all of these things in different ways, but we can find all of these requirements in all living organisms. And then viruses come in, and the system kind of falls apart because while we define living organisms using these requirements, it's also very easy to define non-living organisms by doing the opposite of these requirements, right? So when we look at, for example, a table, it's going to meet none of these characteristics, so it's a non-living thing. We don't have um, any things that are kind of in between that only meet some characteristics, except viruses. Viruses are the ones that really stump us because they're not black and white. So what do I mean by that? Viruses meet some of these requirements, but not all of them, which is very confusing when we're trying to classify them. Let's listen to Tala Hamad's answer. She's one of my biology students, and she recently did a presentation where she actually answered that question of whether viruses are living or not. All right, so she does a great job at answering this question. She also makes a lot of great points in her whole presentation, which I will be sharing with you with the extra resources section. She also mentions that you cannot really kill it because it's not considered alive, and that's a great point. And if you notice, the vocabulary people are using during this COVID-19 crisis is treating COVID-19, a virus, as if it was alive, as if it could be killed and it could be defeated. So in the public consciousness, we kind of think of viruses as being alive. However, as she said, they don't meet most of the criteria for being alive. So they're not made out of cells. They're made out of genetic material, which can be DNA or RNA, a protein capsid, so a protein shell that protects the genetic material, and maybe a lipids envelope around it. But it is not a cell. Let's leave the reproduction part for now and move on to energy and nutrients. So they don't need any energy or nutrients to continue existing. And they don't grow and develop. So once they are assembled, once they are put together, they don't change. They do respond to the environment, and that's how they infect different cells. But they do not have a metabolism and they do not maintain homeostasis. Now let's go to the able to reproduce and pass traits to their offspring criteria. So the reason why this is so hard to answer is because they kind of are able to reproduce and pass traits to their offspring. After all, if they weren't able to reproduce, we would not have this pandemic at the moment, right? We need more than one virus in our bodies in order to make us sick. There needs to be many, many viral particles. And to do that, they need to be able to make copies of themselves. However, the reason why this is controversial is because they don't have the machinery to do it themselves. So all living organisms can reproduce on their own, pretty much. Whether that is asexually or sexually, if they need a mate, they are still able to produce offspring using the tools that they find within their own organisms. Viruses do not have these tools, so they're only pieces of genetic material, proteins, and lipids. They don't have the machinery to produce offspring. What they do is instead of just producing a virus from a virus, they need to infect a cell first and use their machinery to be able to produce viruses. So what viruses are doing is they're going into the cell and they take over. They use the proteins, the DNA, all of the tools that the cell has to be able to reproduce itself. They steal them and they use them to instead make more copies of the virus. So the answer to that, whether they're able to reproduce or not, is kind of shaky, maybe, right? Yes, they can, but only if they steal the tools from somebody else. So they have more check marks in this list than a table would, but they have fewer than living organisms do, which is why we don't really consider them living, even though we treat them as if they were living. We speak of them as if they were living. So, as a summary for this workshop, there's going to be an online discussion about why we consider viruses living, why we consider viruses non-living. And I also want you to include, your own thoughts about this. You have been hearing everything about viruses as if they were living organisms. There seems to be a confusion in the public mind about whether they're actually living or non-living. Now you know the biology behind it. You know the definition that we use to define living beings. So, what do you think?